Hello friends, the topic of our presentation is design and simulation of hybrid power system for Woody Island Resort, and it is a part of the course Renewable Energy Systems supervised by Dr. Tariq Iqbal at Memorial University of Newfoundland. So the table of contents will cover the objective, introduction, methodology, system configuration, dynamic modeling, control design, results and discussion, and it will cover references. So the objective is designing the hybrid power system for an isolated community which are far from electric grid, and calculating the load data for this isolated community in Energy 3D software. And the sizing of the hybrid power system is done in Homer Pro software, whereas the dynamic modeling of the design system is done in MATLAB, and controlling of renewable energy systems is also done in MATLAB. Here you can see in the figure there is a hybrid power system for an isolated community. There is a wind, there is a solar, there is a battery backup, and there is a load, and it is for the isolated community. So now let's talk about hybrid power system. What is hybrid power system? The power system which generally generate energy from conventional energy resources. It might be one conventional energy resources or two conventional energy resources, and is generally referred as hybrid power system. And the types of hybrid power system are hybrid power system can be with conventional energy resources, it can be with the non-conventional energy resources. Hybrid power systems can be installed with energy storage facility, and it can also be installed without energy storage facility such as batteries. Now, what is standalone system? The standalone system is the system which generates the power through renewable energy resources, and it is not connected with the grid. Sometimes there is a issue that there is no solar energy resources or wind energy resources. So this standalone system can generate the power through a diesel generator, or through any other fuel. So the site selection is Woody Island Resort, which is located in Newfoundland, and there are some houses which can be seen in the figure over there. And for this, the hybrid power system is to be designed. So before designing the hybrid power system, there are few points which we have to consider. One of the main significant point is available resources, and for the Woody Island Resort, it can be seen in the figure that the solar irradiation data and wind speed data is shown. The highlighted is the highlighted by a circle is the Woody Island Resort, and it can be seen that the solar irradiation is 950 kilowatt hour per kilowatt per year, and the wind speed data the highlighted is for summer, because as the load is active for 3 months in a year for the Woody Island Resort. So the summer has mean wind speed is 6.41 meter per second with another data. So it can be seen for designing the hybrid power system for Woody Island Resort. The map is shown for the Woody Island Resort, and the houses are circled. So for these all houses were designed in Energy 3D, and in total 19 houses were designed to obtain the load data. The For the month of June, July, and August, as the load is active for June, July, and August. And this all load data were entered in Homer Pro for the sizing of renewable energy, for the sizing of the system using renewable energy resources.
Hello friends, my name is Karan Patel. Further, I would like to continue the presentation from the topic of methodology for the Woody Island. As we are developing the hybrid power system only for the 3 months between the month of June to September, there are very less population or resides over the Woody Island. Between the springtime, only for the tourist excursions, like the energy consumption can be seen over there, for which we are using diesel generator, solar system, and windmills. We are using them, and we are planning to develop the hybrid system in the Homer Pro software. Further, in this slide, we can see that the micro hybrid system developed designed in a Homer Pro software, in which we have two grids we have taken for the different energy generating sources, and the components and the ratings of the which have been used for the development of the hybrid system are shown in this slide. Moving into system configuration, in which, as we have previously seen about the data for the natural resources availability, such as solar irradiations and the wind speed at the Woody Island, we have developed the hybrid system, which in which consists of solar PV system and the wind turbine. The ratings are the shown in the slide, as well as diesel generator is also used for the development of the hybrid power system as a backup power supply. Also, for the energy storage, battery storage system is also used, and the rating of all the components are seen in the slide. After the developing the model in a Homer software for the microgrid hybrid system for the Woody Island, we optimized that system, in which we got like four different combination of the energy generating unit to generate the power electricity and supply to the load, in which all the combinations are seen in the table, in which it can be seen that the 72.1% is the total renewable fraction for the energy generation, and 27.9% is the diesel generator fraction for the fulfilling the load demand. Also, by fulfilling the load demand means supplying the total load, as well as for the battery system, charging is also considered in it, in which daily charging capacity is around 30.7%. For the economic point of view, system having both the wind and solar resources comes out very feasible solution. It can be seen from the table. After the designing the micro hybrid system for the Woody Island, the result we have achieved is shown in a graph, in which it can be clearly seen that the wind turbine is majorly generating the electricity for the Woody Island, whereas solar system is the second in the electricity production, whereas the diesel is generator is very least used for the electricity production, in which throughout the year 120,661 kilowatt hour unit of electricity is consumed from the various electricity production units. Coming to the cost analysis of the system, from the right side the bar graph which shows about the total investment of the system annualized base, in which it can be clearly seen that the capital cost of the system is quite high as compared to the operating and fuel cost, in which specifically solar system and the diesel generating system are the more expensive to develop the micro hybrid system. Moving towards the left side, the line graph which shows the data of the cash flow in a system, in which it can be clearly seen that the total investment is the highest, then the further for the next 20 years the investment will be reduced, and afterwards we can get the return on our investment, in which we can get the slightly increment in the cash flow graph. Now further our group member Arsh will be continue for the presentation.
In this part, we're going to use MATLAB Simulink for modeling the system dynamically. To achieve this purpose, we're going to analyze and simulate the system behavior, such as changing some dominant parameters like wind speed, solar radiation, load demand, and check the results such as stability, reliability of the system, and state of charge of battery. And here, as it recognizable, we have a Simulink model of the system. We have 3 decentralized generators and 1 energy storage system. From up to down, we have a diesel power generation system, PV system, battery backup system, and wind turbine system. In the diesel generator part, we have an exciter to turn the diesel generator on and off, and using a breaker as a protection to connect the diesel generator to main grid. In the PV part, we have a solar panel, a DC-DC converter, and an inverter, output LC filter, and again a breaker to connect the PV part to main grid. We have a battery backup system, we have a wind turbine and wind turbine generation to connect to main grid. In this section and following section, we're gonna change some dominant parameters such as solar irradiation, load demand, and check the results of output parameters such as output voltage, currents, and output power, and also a state of charge of battery to check the stability and reliability of the system. And here we use a step function to decrease the solar irradiation from 1000 to 500 at the moment 0.2 seconds to check the output parameters and also state of charge of battery. As we can see in the right picture, the state of charge of battery starts to decrease slightly, but this amount during 1 second is insignificant because based on a simple calculation, we know that it takes almost 51 hours to discharge the entire battery. And on the other picture, we can see that the output voltage and currents are still stable. That means that output current will be still stable as well. And here we have a PV control system which has been designed to keep the power point at the maximum level. To achieve this goal, we used a MATLAB function which has been coded, and the strategy of this code is shown here in the flowchart. Here we sense the voltage and currents of the PV system, calculating the power and comparing the power and voltage with previous levels to intentionally increase or decrease the reference voltage, to change the duty cycle of the switch in the boost converter, to keep the power point at a maximum level or increase the power point to reach to maximum level. As we will see in the following section, the PV system is stable while any change in solar irradiation or in a load occurs. We see here that after any change in solar irradiation or a load demand, the PV system finds the maximum power point after a short time and still remains stable. And here we have the diesel generator control system. To achieve the goal of controlling the diesel generator, we use this diagram to sense the voltage and current of loads to calculate the load power, and using the condition as a limit of 40 kilowatts. When the load power is more than 40 kilowatts, we turn the diesel generator on, and when below it, we turn it off. By using this simple strategy, we can satisfy the results of the Homer as well.
So these are the references which were used for the project as a reference. So thank you for listening our presentation. If you have any questions, you can ask, or you can also and enter the question in comment box. And I'm thankful to my project partners, and I'm also thankful to my supervisor, Dr. Tariq Iqbal, for his guidance. Thank you.